Today we have Mikail talking about SpringerMaterials. Well, go ahead. Let us know what's going on there.
All right. Hello, everyone. This is Mikail Shaikh. I am an eProduct manager in Ray Cologne's group of eProduct management at Springer Science. And today I will be talking to you really briefly about SpringerMaterials. And unlike the other presentations that we typically do where we talk more about what the database represents, I think this Hangout should be more of a quick and dirty how to use SpringerMaterials. So all I'm really going to do today is walk you through a few examples, and if you have any questions, then I'd be happy to address them. Is everyone okay with that?
Yeah, perfect. I just muted my microphone just in case for background noise.
Okay,
Go
great.
ahead.
All right, so if you can show my screen, then we can have a live demonstration.
Yeah, everybody just has to select your screen, and then it will pop up as bigger screen.
Okay, great. All right, so in that case, I'm going to start off with a couple examples. So let's start with the home page. When you type in www.springermaterials.com, you end up with the page as it looks right now. I guess that's my video stream. You cannot see me, but you can see the home page of SpringerMaterials. And in the center, there's a nice, pretty search bar, quite similar to Google. So the point of the search bar is exactly the same. It is the start point of our search journey. So what I'm going to do is I'm going to type in something very basic there. I'm going to type in methanol. And as you can see, as I type in the word, it gives you a drop-down list of likely options. So I'm going to click on the first one and hit go. So that's going to, this is the most basic, simple search routine in SpringerMaterials. And as you can see, we have about 2,060 documents in total. And all the documents all the search results are shown in the center, but on the left-hand side, you can see the various subject areas. And you can see numbers next to them. The numbers represent the number of documents within those subject areas. So obviously, methanol being a liquid, there are more documents in the thermodynamics section and in the thermophysical properties, and much less in the others. But this example does highlight a couple of key features of the search platform. For one, all the search results will be populated in the center, and you can create filters using the subject areas on the left. So what I will do right now is I will just click on the thermodynamics section just to show you how it looks. And as you can see, you have a different set of results. And the first set that you can see there on the left, from particles, atoms, and nuclei all the way to astronomy and geophysics, that represents the collection from the Landau-Bernstein series, which, as you all know, is a very well-renowned series that has been around from the 1800s. And the point of this database was to create a functional relationship between materials and their properties. Below that, you can see a couple of other databases. The first one is the Inorganic Solid Phases, and this database is mostly about the inorganic properties of materials. And since methanol is a liquid, most of the information here will be using methanol as a solvent. And below that, you can see thermophysical properties, which is a subset of the Dortmund data bank of software and separation technology. And I'm going to click on that just to show you. And as you can see, this gives you the thermophysical properties of methanol and the methanol mixtures. And last but not least, we have a very valuable section called Chemical Safety, which talks about the European regulations for chemical safety. And one might always think that, hey, this is only relevant to Europe and not from the Americas or Australia or Asia. Well, the way I like to look at it is that if it's going to kill you in Europe, it's going to kill you in Asia too. So I'm not really too worried about it, the European regulations part of it. Anyway, so what I just showed you is a simple search routine. I'm going to go back to the home page now. When I could, so the first thing that I did was did a search using the search bar. What I will do now is navigate instead. So along with searching, you can actually navigate using the subject areas on the left. So I'm going to click on crystallography, and as you can see, we have a number of sections on crystal structures, atomic defects, and surface chemistry. Clicking on diffusion in semiconductors, and I'm going to click on diffusion in silicides. And as you can see, it's going to bring up the full text. Now, what's really important to recognize is that the entire search platform for SpringerMaterials is free. You're able to navigate, browse, and do all the search routines that I'm about to show you today. But accessing this last document is a subscription-based model. So you can do all your searching and navigation, and when you want to view this page, and as you can see, it has formulae, acknowledgements, a lot of numerical data, and this is what you need a subscription access for.
So do you get a preview of the article, or
yes,
like the abstract, or?
Yes, you do. So I'm going to go back to the previous page right now, just to show you again. So I clicked on diffusion and silicides, and as you can see next to them there are two icons. There's a PDF icon and an I, which is the information page, which is gives you a summary of all the information that's in the document. So I'm going to click on the information page right now. And as you can see, the information page has a lot of detail. You have the download button that will take you to the full text version 2. But you also have a couple of thumbnail previews. And these thumbnail previews are really relevant when you're a scientist, because very often what happens is if there are graphs, each graph from a different measurement technique will have a particular signature shape. So a scientist even can look at the thumbnail and determine whether that's a particular document he wants without having to open it. For example, a spectroscopy graph is very, very different from a crystal structure. It's very different from any other measurement technique. So it really helps you to get a quick overview of what the document contains. But what's really relevant here is that you have a citation tool that allows you to export the citation for this particular document in a format that EndNote will recognize. So it's easy to integrate this particular document into your research workflow. So that's one of the interesting things that the info page can give you. As you can see, it has chapter concepts. And more importantly, right at the bottom, it has a list of references with cross-ref links. So I can actually click on one of these cross-ref links and go to the original document that was referenced in this SpringerMaterials article. Now note that this does not mean you have access to these references. It just means that it will display this literature reference in its original location. So if it's a paper from Springer, it will take you to the Springer link page. If it's on Science Direct, it will take you there, etc. Obviously, if your institution has access, you'll be able to access the full text document, but it will actually show you the abstract. Okay. Any questions regarding the information page?
Well, you can't see whether it's a Springer journal. I mean, like on PubMed, you see a link to the full, like this crossref thing. But next to it, if it's a Springer article, then it will also have a link to Springer link with a little Springer icon.
That is correct. No, so these articles are sourced from all publishers, so there's no preferential treatment given to Springer at this point.
Okay.
Okay, so I'm going to go back to the home page now. So we've seen two styles of navigation, one style of search, one style of navigation, which is according to subject areas. And right next to the subject areas is another link called Bookshelf. And if you click on that, it's going to give you the same content, only this time it has been rearranged according to the original Landolt-Bernstein series system. So these are the groups that were originally devised in the 1800s. And this would be very relevant to researchers who are familiar with the original series, librarians, and other archivers. But it's, in my personal opinion as a material scientist, I would say that these groupings are more general. In today's world, condensed matter is too broad a subject to be just called condensed matter. It comprises of semiconductivity, magnetism, superconductivity, and using the subject area navigation, it's much clearer and much more intuitive. So depending on what your background is and which generation you're from and how familiar you are with the Landolt-Bernstein series, you can choose to navigate via either the the subject areas or the bookshelf. So, but the bookshelf still remains quite a valuable way of navigating and browsing and discovering related content. So the bookshelf is the second tab, and the third tab to the right of it is the periodic table. And this is a rather nifty search feature that's quite unique. I don't know how many other software or platforms offer this. So what you can do here is actually click on elements to form your group. So if I'm working on a stainless steel, and I know stainless steels typically contain iron, and I'm clicking on iron, chromium, clicking on chromium, and nickel, clicking on nickel. And as you can see, every time I clicked some of the options grayed out. That means that we don't have content on those options. And on the left, it is generating a list of elements that you've clicked on. And as you can see, the top hit is chromium, iron, nickel, just like I selected. But it also gives you other suggestions. So our system predicts that aluminium would be an addition to this material system, and that's what it's showing you on the left. But if you're interested in the system of stainless steels, you can click on that, and it's going to take you back to the search results and give you information in that way. So the periodic table search is quite a unique way of selecting materials, and this is really relevant when you're dealing with multi-phase systems. So that's one of the cases where this is really relevant. And the other is when you're dealing with geological systems where mineralogy dictates that there will be partial stoichiometry, whereas when you see elements not combining in integral combinations but fractional combinations. So that's when, if you want to avoid typing in the fractions, it's quite valuable to search via the periodic table. And eventually it does bring you back to the original search results.
A naive question, but does it only contain chemistry articles? Or, for example, if you're looking for, I don't know, calcium, does it also show up some biomedical articles?
No, so SpringerMaterials is basically a database of physical and chemical properties in material science only. So although biomaterials do constitute a small fraction of it, our major focus is towards inorganic materials and organic materials. So
okay.
No medical articles at this point.
Okay.
Okay, so moving back to the home page, I've just shown you 4 different ways to navigate our content. That was searching, navigating, bookshelf, and periodic table. The next link that I'd like to show you is called Advanced Search. So clicking on Advanced Search, you can see that we have 3 different tabs here. And the Advanced Search really gives you a way to search for something exceedingly specific. So if you're looking for something very, very in-depth, this is where you go. So what I'm going to do here is do a sample search again. I'm looking for a very well-known material system called aluminium, gallium, arsenide. And if you click on it, it's going to you can click from the drop-down list. And if I'm looking for a specific property of a semiconductor material, and the most basic one is an energy gap, I can type in the properties and energy gap and select from the list again. And I know that I'm looking for only results from the semiconductivity section, so I'm going to click on semiconductivity from the subject filters on the left at the bottom. And when I hit go, the first document is the energy gap. So this is a way to find something very, very specific. And again, if you click on this document, it's going to give you the energy gap. So this is the way if you know exactly what you're looking for and you know all the search terms, you can do a really quick and efficient search this way. Another really cool feature of the advanced search is if I type in the name of a compound, again, I'm going to use methanol as a base example. You can see that even though I typed in just methanol, the system is predicting methanol, is giving you a bunch of numbers, which is a CAS registry number, which is a way that all materials have been classified, and it's very familiar to people who are using these CAS numbers, especially chemists. And you can see the molecular formula on the right. So I need not have typed methanol. I could have put in CH4O, or I could have put in the CAS number, and it's going to find all the research results. So it makes sure that your search is very comprehensive, but yet can be very specific. The next tab over is called the 3D molecules, and this gives you a visual representation of a molecule in 3 dimensions. And again, to take an example, I'm going to type in pyramine just because methanol is getting boring. And clicking on pyramine is going to open a new tab, and you can see this molecule in 3 dimensions. And the molecule does rotate on its own, but you can click and drag it to rotate it according to your preference. And here's this particular angle is one of the reasons why visual representation is really important. As you can see, this particular molecule, even though it does look planar, in reality it has a slight, one of the 2 benzene rings has a slight offset. So this is one of the things that you really can't make out in 2 dimensions, and that's where 3D representation becomes really important. And you can also stop the spin and do actual measurements. So this is not all prettiness. You actually can find things like the bond length. So as you can see, I've measured the bond length between these 2 carbon atoms, and it tells me that it is 0.14 nanometers. Also, you can determine the bond angle between these. And obviously for a hexagonal structure, you can see that the bond angle will be 120 degrees. So, and on the right, obviously, you have actual documents from SpringerMaterials. So it's a great way to visualize. It's a great teaching tool. It's a great learning tool. And it does give you useful information too. Okay. And last but not least, we have something called a bibliographic reference search. In this, you can actually search for a preferred author if you know a particular author is highly active in a particular field, or if you're looking for articles from a particular journal, you can use the bibliographic references search. So what I'm going to do is I'm going to type in the name of a journal, and to show solidarity for SpringerMaterials, for Springer, I will type in the Journal of Materials Science. And as you can see, there are a number of hits. There are about 43 pages worth of references from the Journal of Materials Science. So it is a good way to determine whether, and you can see from the first couple of hits, S.C. Agarwal has been a pretty prolific author, and a lot of his work has been included in SpringerMaterials. So it's a great way to follow a certain journal or to follow a certain author. And in that, I have rounded off all the current ways to search in SpringerMaterials that are available as of today. There are a couple of new features that will be introduced in the next couple of months, which will include a chemical structure search that is not currently available but would be available within a few weeks. It's a great tool where you can actually draw a chemical structure and do a search quite similar to the periodic table. So just like on the periodic table, you can select elements. In the structure search, you'll be able to select a benzene ring and put on a nitrogen atom in the ortho position, or attach on a second benzene ring to make anthracene or pentacene, etc. So these are the search ways for SpringerMaterials. If you have any questions, please feel free to ask me right now. Thank you.
Yeah, I'd like to ask a question. The biggest journal we publish at Springer is the Journal of Material Sciences. What you've built here and what you've got here is a beautiful interface actually to access material in a much more enhanced way as we normally do with Springer Link. So is there any plans to use this interface also to access the papers from that journal and allow authors to submit the material that way so that you have the enhanced visual features and stuff like that?
Yes, there are plans to be able to allow authors to directly contribute to SpringerMaterials, but that will involve quite a substantial investment of programming on our part. So currently, they are looking at other enhancements, but that is definitely something that will be coming in the very near future.
Yeah. Okay.
The purpose of SpringerMaterials is to give you authenticated and definitive information across publications. So it's not just Springer or that contributes to this database. It is authors who are experts from the field globally. So we will invite people from all countries from all publications to contribute to this database. And that would be a truly collaborative effort that hopefully we can realize in the short future.
Very nice.
Yes.
Okay. If there are no further questions, then thanks a lot for your time, and thanks for explaining us more about SpringerMaterials. And I'll send the link around to everybody to this to the YouTube movie that should be on my profile anytime soon.
All right, great.
Okay.
Thank you very much for your attention, and I look forward to seeing myself on YouTube.
Well, you're not on YouTube because we only see your screen, so.
Yes, that's the good part of it.
Okay, thanks everybody. Bye-bye.
Thank you.
Thank you. Have a great day.
Bye-bye.